Hi everyone, I am Vidya from the Department of Artificial Intelligence and Data Science. My role in this hackathon is building AI to the deepfake detection system. My responsibility in this project is the brain, the machine learning model that actually detects whether a video is real or fake. Let me walk you through the what I built. First, why did we need AI at all? Deepfakes today are so realistic that the human eye simply cannot catch them. Traditional software cannot catch them either. We needed machine learning because only AI can find the patterns that are invisible to us. Now, I built three separate AI models and each one looks at the video differently. The first model is CNN, Convolutional Neural Network. This model looks at individual video frames like photographs. It examines the face and searches for visual clues of manipulation. Things like unnatural blending around the jaw or hairline, lighting that doesn't match the background, or skin texture that looks slightly off. I used a model called EfficientNet before, which is trained on over 1 million deepfake samples. It gives each frame an anomaly score between 0 and 1. The second model is LSTM, long short-term memory. Now, here is where it gets interesting. CNN looks at one frame. LSTM looks at 64 frames together as a sequence over time. This is important because some deepfakes look perfect in a single frame but fail when you watch them over time. LSTM catches things like a blink rate that is too fast or too slow compared to a real human, facial movements that are unnaturally smooth, or micro expressions that suddenly glitch between frames. These are things you can only catch by watching the video as a sequence, not frame by frame. The third model is FFT, Fast Fourier Transform. This one is my personal favorite because it catches what both CNN and LSTM completely miss. When an AI like StyleGAN generates a face, it leaves behind invisible noise patterns in the image. The human eye cannot see them. CNN cannot see them. But when I convert frame into frequency domain using FFT, this patterns show up clearly as unusual spikes across the frequency spectrum. I divide the spectrum into 48 bands and measure how much it deviates from what a real camera naturally produces. High deviation means a GAN was involved. Fourth, audio verification. I also added audio analysis. Many deepfakes focus only on the face and forgot about the voice. I check whether these lip movements match the audio timing. If the offset is more than 40 milliseconds, which is the limit of human perception, this is the strong signal of manipulation. I also analyze the voice itself to detect if it was generated by a text-to-speech system. Finally, the fusion engine. Each model gives its own score. My fusion engine combines all four scores using weighted averaging. CNN gets 35%, LSTM gets 30%, FFT gets 25%, and audio gets 10%. These weights were carefully tuned based on model performance. The fusion engine then produces one final verdict: real, fake, or AI generated, along with a confidence percentage. The reason we built three models instead of one is simple. No single model is good enough on its own. A deepfake that fools CNN might fail LSTM. One that passes LSTM might get caught by FFT. By combining all three, we create a simple system that is much harder to fool than any single model alone. This is what gives Deep Shield its 97% detection accuracy. This is how our Deep Shield website looks like. It has the features of uploading any videos or video URLs. If I just uploading a video in my system, it will analyze the video step by step by using the models of CNN, LSTM, FFT, and finally it verifies the audio. Then it will detect the video is fake. It also shows the heat map of fake detection. This is all about our hackathon project. Thank you.